Karpenter is responsible for managing your worker nodes in your Kubernetes infrastructure. For example, if you have insufficient node capacity to create and place new pods, it should create a new node. If you have more nodes than your workload needs, it should destroy the needed nodes. What's the difference between cluster autoscaler? Mainly that first you use fewer configuration. Second is that it does automatically a lot of things that you have to manually describe when you have autoscaling groups and cluster autoscaler. The third one is that Karpenter combines functionality of 4 more tools like custom scheduler, descheduler, node termination handler, and cluster autoscaler. Labeling of the nodes is also done automatically based on the node it would create, spot or on demand, and it's also more cost efficient. Why? Because these automatic decisions. Why I mentioned that with Karpenter you have fewer configuration. I'll show you examples from our infrastructure. We had static 8 spot groups with different instance types and with different priorities. We had the same for example 8 on-demand groups. Now instead of these 16 code blocks for auto-scaling groups, we had one node pool in which you have described spot and on-demand, 3 family instance types and some generations. It automatically will decide if it will create spot or not, or on-demand. On-demand will be created only when all the spots are over, which is a very few chance. Also, we save describing the labels, which we had to do manually when we were using auto-scaling groups. Now Karpenter label the nodes automatically based on the information and the node if it's spot or on demand. If you are using Terraform for deploying Karpenter and you are worrying about how to not mess your current load with your new workload, first it's worth to mention that Karpenter does not have dry run mode. Its equivalent of the dry run mode is just not to have a kind node pool. When you don't have node pool, there is no chance of new nodes from Karpenter to be provisioned, and they get messed with your current workload. Second tip is that on initial deploy you may set count on the Terraform resources, thus they will not be created in the next environments, only in the environment you have restricted to with count resource. Third one is that you may have some kind of Karpenter switch that is use Karpenter true or false, and when it's true you scale down everything code like spots and on-demand manually described auto-scaling groups, along with all deployments like cluster autoscaler, node termination handler, and custom scheduler. If use Karpenter is set to false, you do exact the opposite. You scale down Karpenter, which will destroy its nodes, and you scale up the autoscaler. This way you have very easy switch with, in bad scenario you can revert Karpenter. A little bit about the components of Karpenter. We need 2 YAM roles, one for Karpenter controller and one that will be directly attached to the nodes. We have 2 policies attached to them, along with 2 assume role policies for them. The first assume role policies is the one for the Karpenter controller and the service account that it's running with. The second assume role policies is with permission to the EC2 AWS service that will be used by the nodes themselves. Separately, we have SQSQ plus CloudWatch events that are monitoring the health of the instances and send these events to the SQSQ. SQSQ then is collaborating with the Karpenter controller pods, and Karpenter controller pod YAM policies have to have SQS receive permissions, which I didn't saw in the official documentations, and our gracefully termination of the spot events was not working because of this reason. Second things regarding the YAM permissions is the KMS policy. They are not setting the KMS policies in the Karpenter YAM policies in their documentation. They have another documentation that was not working for us. Why? Because our KMSK is in another AWS account, different than the one for the applications and the Karpenter. So we had the KMS policy for the key set in the different account, whereas the KMS key, but in order for Karpenter to properly have permissions to that key, we had to grant KMS grant access permission to the controller. The other two main components that are measured for Karpenter and which control your nodes are Kubernetes resources kind node pool and kind EC2 node classes. What's the difference? Kind node pool is managing the nodes, creating them, and it's responsible for describing what kind of instance types, families and generations it will have, while you can look on the EC2 node classes like a skeleton for how these nodes will look like when it comes to their security group, subnets, AMI image, and the custom thing for us was that we don't want these nodes to be joined in AWS System Manager. First, because we don't have direct access to them, and second, not to confuse people in their searching list. What we needed to do in order to remove them was just to remove the SSM permissions from the Karpenter policies. The last one was not so important, but the next one is what we noticed yesterday is that during EKS upgrade to newer version, control plane has been upgraded, but the nodes were not replaced with the new AMI version. Why? Because the workload had pod disruption budget and Karpenter respect the pod disruption budget. So there is a difference between voluntary termination of the nodes and spot events from AWS that terminates the nodes. First one is respected, and when you have pod disruption budget, these nodes can't be immediately terminated, while if AWS sends a signal for spot consolidation, they are directly replaced. But we don't want to wait for that, and I didn't saw anything we can do at that point. So we had to manually invent our new resource and custom logic that when the control plane version has changed, it destroyed the workload. One more thing it's worth to mention with respect to custom scheduler and the scheduler, and why we don't need them anymore but we needed them before that, was because the native Kubernetes scheduler is placing the pods on which nodes which it wants. For example, if we have two nodes and one is utilized on 80%, the other one is 10%, it may schedule the pod on the underutilized node. This way we had a lot of underutilized nodes, and we we had the descheduler to remove this pod from the underutilized nodes and the custom scheduler to place them on the most utilized nodes, and this way we could terminate the underutilized nodes. Now we don't need these two tools, and we can remove their deployments, because Karpenter automatically rebalance these pods across the nodes in the most efficient manner. Did it work? Yes, our costs had been decreased with 48%, which is very good. Ultimately, I have a lot more to say because I've been working on that project for 2 months, and we had another issues, like one, for example, I remember it was that if it spin up a new instance with certain number of CPUs, higher number, I remember 64, if it creates such a node, our workload was not working, and we couldn't understand why. We temporarily removed this instance family from these nodes and these generations. But I think to create another video if you are interested with all the issues we had in the future, because in the future I believe a lot more will be arised and our expertise will get higher. Currently I'm not a Karpenter expert, but I believe this was a good quick summarization why we switched from cluster autoscaler to Karpenter, and what we received and what we saw and what was our CI approach.